Hi everyone, this is Mrs. Musoff here. Today we're going to be talking about rates of change, and part of rates of change is also going to be both secant and tangent lines. Alright, so as a reminder, we talked about this a little earlier in the chapter, average rate of change, which remember anytime we talk about a rate of change, in your head you can kind of imagine that's the same kind of phrase as slope. Right, so if you ever notice the word slope in here, it's kind of interchangeable with rate of change in terms of what we're looking for. Right, and so remember, average rate of change, that's the change in y divided by the change in x. Or in our functions, we like to use function notation, so f of x minus f of c divided by x minus c. Remember, always do the end minus the beginning when we're trying to calculate the average rate of change. Alright, and in this first example, that's just kind of what we're going through. Find the average rate of change of this given function, x to the third minus x, over the interval 1 to 3. Now remember, interval here in this context, these are x values. Right, so it's like x1 and x2, or x and c if you wanted to label it. But just make sure when you're then substituting it into your average rate of change formula, you do the end x value minus the beginning. Just to ensure that you have the correct average rate of change. All right, and so that's what we've got right here. We've got f of 3 minus f of 1 divided by 3 minus 1. And all we had to do was substitute some values into the functions, all right, get our y values, subtract, and simplify. And so our average rate of change from 1 to 3 of this function ends up being 12. All right, now we're going to kind of apply this to something new today, because what we want you to recognize is what we just found here. If I think about these kind of now as 2 points, right? So f of 1, that ended up being 0. So that was the point 1 comma 0. And f of 3, that ended up being 24. So that's the point 3 comma 24. And so those are the 2 points I have labeled here, 1 comma 0 and 3 comma 24. And when you calculate the average rate of change, since that's the same thing as slope, what you're really calculating is the slope of the line that's formed by those 2 points. And we call that the slope of the secant line between those 2 points. A secant line is a line that passes through at least 2 points of a function. All right, and so this is defined as a secant line. We just found the slope of it. Well, that's helpful, but a lot of times we actually want to find the slope of the tangent line. A tangent line is a line that just touches a function. All right? And in order to do that, what we're going to do, and that's what this little statement right here says, is we're going to bring this second point closer and closer and closer along this function. And that means that line's going to change slightly, and as we bring it closer, we're going to be calculating that slope, and eventually it'll turn into the slope of the tangent line. And to try to demonstrate that, I'm going to show you on my calculator here. Alright, so what you see here is this is the function I was just talking about, x to the third minus x, with the point 1 comma 0 and the point 3 comma 24. And so this red line is the secant line, and the slope of that line is 12. That's what we just calculated. Well, in order to find the slope of the tangent line, what I want to do is bring this red point closer and closer and closer to the blue point. And so let me kind of show you how that works. As I bring it closer, that secant line changes, right? The slope is different. It's kind of flattening out in this case. And as I bring it closer, eventually, once that distance between those 2 points is 0, it should be right there, now what I have is actually a tangent line. And that tangent line, that's the slope that I'm going to be finding. Okay, so just to kind of give you an image to go along with it. All right, now the slope of the tangent line, it sounds like something brand new, but we've actually talked about it before because that's the same thing as the instantaneous rate of change. Right, so way back when, I think at the beginning of this unit, we talked about average rate of change and instantaneous rate of change. Well, now we're just basically calling those different things. Average rate of change, that's right here. That's the slope of a secant line. And instantaneous rate of change is the slope of the tangent line. So from now on, depending on which words you see, just make sure you know how to connect it to what we've already learned. Okay, so the slope of a curve at a point, or the slope of a tangent line, that definition is right here. The slope of a function at a specific point is M, that stands for slope, remember, equals the limit as h approaches 0 of f of a plus h minus f of a divided by h, assuming the limit exists, right? If the limit doesn't exist, then there is no slope, okay? But if the limit exists, this is how we'd calculate it. And again, this should look familiar because this is the same formula we used for instantaneous rate of change. Okay, so for this first example, or this, I guess the second example, it says find the slope of this function at x equals 3. Find the slope of f of x equals x squared at x equals 3. Since it's only giving us one x value, that's how you know that it's the slope of a tangent line, right? For it to be the slope of a secant line, you would need two x values, okay? One x value means slope of a tangent line or instantaneous rate of change. So I would write down, my formula here, but in this case, a is going to be my x value. Okay, so in this problem, a is going to equal 3. Now h, remember, is going to stay a variable because we're calculating the limit as h approaches 0. So I don't want to plug anything in for h, I want to actually evaluate that limit at the end. All right, so I am going to plug in 3 for a, and that's what I did right here. And then f of 3 plus h, that means taking 3 plus h and plugging it into my function, so 3 plus h squared. And same thing right here, taking 3 and plugging it into my function, so that's just 3 squared. And then all I did was evaluate, right? I distributed this out, simplified, 9 minus 9 is 0. Okay. Now these steps are the really important steps, just like we talked about last time, way back at the beginning of this chapter when we went over this. We really want to make sure you show us how you are simplifying this function. So I want to see that you can factor out the h, and that's what allows you to simplify those h's. Okay. And here, now it says find the limit as h approaches 0 of h plus 6. Remember, most simple limits you can just substitute that value in, as long as you don't get undefined. I'm not going to get undefined here, so that means I can just substitute the 0 in for h. 0 plus 6 is 6, and that would be the slope of this function at x equals 3. In other words, this is the slope of the tangent line at x equals 3. Just to kind of remind you of different wordings you might see. Okay, so again, this is kind of a slightly new application for it in terms of the wording, but it's the math that we've already done before. So if you need to look back at some of your old notes to remind you of the math, feel free. This is just to kind of, I guess, show it in a new light. All right, this last example here on the back page, now it says given f of x equals x squared minus 4x at x equals 1. Part A, find the slope of the curve. So again, the slope at a single x value is going to be the slope of the tangent line, which would be our instantaneous rate of change formula. All right, so m equals the limit as h approaches 0 of f of a, which in this case a is going to be 1. So 1 plus h minus f of a, so f of 1 divided by h. And once again, I just substituted it. Now in this equation, I do have to substitute it into two different places, so make sure you're careful about that. All right, for both of these. And so that's what I've got down here. Now, really be careful because that's a lot of pieces you're writing out. It can be easy to get mixed up. So just be organized with your work. I simplified. I ended up with a function where I can factor out the h, simplify those h's. And then once again, I would substitute the value in for h and solve. Okay, and notice what I've written down here. You have to show these steps, and when you plug in 0, make sure you get rid of the limit because that's evaluating the limit, right? It shouldn't still be there once you've plugged in the 0. All right, and there's our slope. Make sure you include m equals so we know what that number represents. Okay. The extra pieces now that we are also going to be adding to it, part B, it says find the equation of the tangent line. Oh, remember, to write the equation of a line, you need two things. You need a slope and you need a point. We already have the slope. That's what we found in part A, right over here. All right, so I know my slope is -2. In terms of finding the point, well, I know the x value because that's what they gave me in the original problem. They gave me an x value. So in order to find a full point, all I'm going to do is take that x value and then plug it into my function, which I actually already did in this equation. Right? But if you need to do it again just to remind you, that's fine too. So I end up with 1, -3. And whenever you have a slope and a point, it's easiest to just use point-slope form, which I've written down right over here. All right, so y minus the y value of my point, which was -3, so y plus 3, equals the slope, -2, that comes from right here, times x minus the x value, which was 1. All right, and you don't have to simplify that equation. We can just leave it in point-slope form. Okay, now part C, find the equation of the normal line. Remember, perhaps, from stuff we've done earlier in the semester. I know it feels like years ago, but it was just a few months ago. Normal is the same thing as saying perpendicular. Okay, which I guess I wrote over here, but why not write it twice? All right, normal means perpendicular. A perpendicular slope would be the opposite slope. That means change sign. So positive to negative, negative to positive. And the reciprocal. Reciprocal means flip the numerator and the denominator. All right, so our original slope was -2. I made it a positive, and then I flipped the numerator and the denominator, and that's how it becomes 1/2. Then we still use the same point, which was 1, -3. Because it is still passing through that point, it's just perpendicular. Right, and that's how we get our equation. All right, I know sometimes this is a lot just because it's a lot of problems we're asking you to do. But a lot of it is, a tiny bit of review and just kind of some limit math that we need to make sure we're feeling good about. All right, so feel free to try this on your own. I'll have another video showing maybe one more example just in case you want to go through it with me. Thanks for tuning in.